Hi, we're David and Marcie Lynn aboard our sailboat 9 of Cups, and we're currently berthed in Adelaide, South Australia. Following is the third in a series of 3 videos that David has put together. In this segment, he'll demonstrate constructing a circuit using point-to-point wiring. We hope you find it helpful.
In the first video of this series, I showed how I tin a fine-tipped soldering iron to prepare it for soldering components to a circuit board. In the second video of the series, I demonstrated how to strip and prep wires and the basics of soldering electronic components. In this video, which is the third of the series, I will show you how to build a complete circuit from a blank circuit board, a schematic, and a handful of parts. I have written a book called Electronic Projects for the Cruising Boat, and one of the projects in it is a high water bilge alarm. This schematic is a simplified version of that circuit, and it's a pretty good introductory project to illustrate how you might go about building an electronic circuit. The water sensor on the left is nothing more than a pair of conductors. They would normally be high and dry in the upper part of the bilge. If the water rises enough to immerse them, U1, which is a comparator, detects the change in resistance and causes the transistor Q1 to conduct. This in turn sounds the alarm T1. The first step for me when I am building a new circuit is to put all the components onto the circuit board. Bend the leads underneath to hold the components in place temporarily. You want to make sure everything will fit, and it's a lot easier to move and rearrange components before they're soldered in. Make sure all the resistors, capacitors, and ICs are oriented the same way. All ICs have some sort of marking that indicates which pin is pin 1. Usually it is either a dot over pin 1 or an indentation on the end of the IC that is closest to pin 1. Your board will look more professional, and you are less apt to make mistakes if all ICs are oriented the same way. Now I will solder the components in place. After each component is soldered, I check to make sure it is flush against the board. If not, you can reheat the joint while pressing on the component. Then I clip off the leads. Keep a finger over the lead as you clip it to prevent it from flying across the room or into someone's eye. This might be a good time to mention that it's a good idea to wear eye protection while soldering and clipping the leads. In this circuit, there are several connections to power and to ground. To make these connections easier, some circuit boards have allotted space for power and ground grids or buses. This one doesn't, so I will make my own bus for the 12-volt and ground connections. To do this, I connect several adjoining pads together using a snipped-off resistor lead. When you are done, carefully inspect each solder joint. You are looking for solder bridges between pins, cold solder joints, or connections with too much solder or too little solder. The previous video in this series has examples of good as well as poor solder joints. The next step is to make all the interconnections between the components. I will arbitrarily make the connection between the bottom of R3 and pin 5 of the IC-U1 first. I took a digital photo of the bottom of the circuit board and used MS Paint to label each component. Then I printed the image to make it easy to identify each component and help avoid mistakes. This is a low power circuit, so I will use 28 gauge solid strand wire to make the interconnections. I will cut the wire about 50% longer than necessary and strip about 1/8 of an inch off each end. Then I heat up the solder joint and solder the wire in place. I use a highlighter to mark the connection I just made. Next, I will make the connection from the top of R4 to either R3 or pin 5 of U1. It can be done either way, and only depends on which is easier. In this case, I will connect the wire from R4 to R3. Continue adding wires until the board is completed. As the wire density increases, it becomes necessary to move wires around to solder the connections. This is why I made sure to cut each wire longer than necessary. Now I will check the circuit and all the connections using a digital multimeter or DMM. I set the meter to the continuity setting and touch the probes together to make sure the meter beeps. Then I check each connection on the schematic. After each check, I put a check mark on the schematic for that connection. Trying to track down a problem later or replacing a blown component due to a wiring error takes a lot more time than checking the connections now. The last step is to see whether the circuit really works. I have a small power adapter to provide 12 volts DC, and I have connected an alarm to the board. This is my simulated bilge. If I dip the water sensor wires into the bilge, the alarm should sound. And like magic, it actually works.
Find more how-to information and travel videos on our blog site at www.justalittlefurther.com or on our website at www.nineofcups.com.